This new section is entitled Gaussian Elimination. Gaussian. The difference between this method and the Gauss-Jordan method is, in Gauss-Jordan, it said in each row, when you find the first non-zero entry, what's above and below it must be zero. Gaussian elimination isn't as strict on that. It says what's below it must be zero. If what's above it is zero, fine, but don't bother to get it to be zero. Whatever's above it is above it. You get what you get. But when it comes to what's below the leading non-zero entry, it has to be a zero. For example, let's go right to the matrix. If you have 1, 2, 1, 2, 1, 3, 2, 3, and 2, 1, 2, 4. Let's solve this by Gaussian elimination. You really want this to be a non-zero number. The only time it can be 0 is if the whole column is 0. Okay, but it's a 1, and we're not going to change that row. But we are going to change the ones below it, because I have to get these to be 0. Well, we all know that 1 minus 1 is 0. That is, why not just do row 2 minus row 1? 1 minus 1 is 0. 3 minus 2 is 1. 2 minus 1 is 1. 3 minus 2 is 1. Now I need to get that 2 in the first row to become 0. Well, if I have 2 right here, and I take away 2 1s, I'll get 0. I'm going to do row 3, take away 2 row 1s. Let's write it out. Row 3 is 2, 1, 2, 4. 2 times row 1, well, I multiply each of these entries by 2. 2 times 1, 2 times 2, 2 times 1, 2 times 2. And I do subtraction. 2 minus 2, 1 minus 4, 2 minus 2, 4 minus 2. Get what I get. Okay, just one little error. When I double each of these, I get 2, 4, 2, 4. I put a 2 by mistake. 4 minus 4 is good old 0. So that is the new row. And you know, I'm actually going to divide every entry by negative 3. And I get 0, 1, 0, 0. So I am done with column 1. Here's my, in row 1, that's my leading entry, and everything beneath it is 0. Column 1 is done. Now I need to fix column 2. You go to row 2. This is a 1. I only want to get what's beneath it to be 0. 1. So I'll just subtract. 1 minus 1. I will just do row 2 minus row 3. I have 1, 2, 1, 2 for row 1, 0, 1, 1, 1 for row 2, and 0 minus 0, 1 minus 1, 1 minus 0, 1 minus 0 is 1. And coincidentally, my leading entries are all 1. If they weren't, I'd get them to be 1. This is, surprisingly I don't have a name for this. I generally call it modified RREF form. I don't have zeros above the leading ones. Now we're going to use some technique called backwards substitution to solve it. I'm going to go backwards. The last row, I'll remember the variables were x, y, and z. The last equation says 0x plus 0y plus 1z, which is z, is equal to 1. Okay, z equals 1. The next row says 0x, which I'll ignore, plus 1y plus 1z is 1. But z is 1. Some number, when you add 1 to it, it gives you 1. You really should know that. It's 0. So y is equal to 0. Top line, it says x, 1x plus 2y plus 1z, which is z equals 2. Now, 2 y's are 0, of course, y is 0, and z is 1. 0 plus 1 is 1. So x plus 1 is 2. Some number, when you add 1 to it, gives you 2. That number is 1. So there's your answer. X is 1, y is 0, z equals 1. Okay, just row reduce it, but don't get the zeros above the leading ones. There's no need to do that. There's no need to do that. It's just a step in the Gauss-Jordan elimination technique that you don't have to do. What I will do now is I'll put down a modified one, and we will work backwards. And the variables are x, y, and z. So the last equation tells us that 1z is equal to 9. Okay, so we have z. The line above says 1y plus 2z's is 8. 1y, or y, plus 2 times 9. Z is 9. Y plus 18 is 8. Negative 10 plus 18 is 8. Okay, y is negative 10. So we have y and z, and still going up, back substitution, we'll find x. We know that 1x plus 2y plus 4z is 7. 1x is x plus 2y. Y is negative 10. 2 times that, you know, how about positive 2 times y? Positive 2 times negative 10 is negative 20. Plus 4 times 9 is 36. And this is supposed to be 7. Okay, x, if you take out $20 from the bank and you go back and you put in 36, you added 16. And the result is 7. What plus 16 is 7? Negative 9. You want to take away 16 from both sides? Fine. But 7 minus 16. How I would compute this is I would do 16 minus 7 and get 9. Positive 9. But when you read a subtraction backwards, your sign was wrong. It's not positive 9, it's negative 9. And I claim that we are done. We have x, we have y, we have z. Okay, just back substitute. You need to be able to look at each of these rows and say, oh, this is 0x plus 0y plus 1z. It gives me 9. And you should know that 0x plus 0y plus 1z is simply z, which equals 9. So we have that. 0x plus 1y plus 2z is 8. Adding 0 x won't do anything to it. Solve this equation knowing the fact that z is 9. 2 times 9 is 18. Top equation, 1x plus 2y plus 4z is 7. Okay, substitute in what you know about y and z, and then you have one equation in just one variable. You can solve that. Okay, this completes the section on Gaussian elimination. We'll do some more of these next section, just a little bit modified.